Okay, another application of geometric series, much like present value, is the concept of saving money. Okay, so this is a very typical situation. Um, when Edith was born, her parents inquired about saving money for her college education. They wanted to deposit the same amount every year into a savings account for 18 years. They set a goal of $300,000. The investment bank said they could earn 4.3% annual interest without too much risk. How much would their annual deposits have to be to reach their goal? Okay, so Edith's parents are thinking, we want to set aside a certain amount of money every year, and then I want to invest that in the bank, and then after 18 years of doing that, earning 4.3% interest along the way, we'd like to have $300,000. Okay, so let's just have an intuitive response here. Let's just say instead of investing it in the bank, earning 4.3% interest, they were just shoving it under their mattress. So they would have to do 300,000 divided by 18. Okay, every year they'd have to do roughly $16,666.67 every year into the mattress for 18 years. They would have $300,000. Okay, so we are thinking that because they're earning interest along the way, they should be able to invest less than $16,666.67 each year. Okay, so we already have an idea of what our answer should be. Something less than $16,000. How much less remains to be seen. And you can see that if we were investing for a longer time, it would be less. If we were investing at a higher interest rate, it would be less. Okay, but 18, just shoving it in the mattress, we're looking at $16,600 roughly. So let's see how this interest helps us. The first thing we need to do is to define some variables. So we're going to let B sub n be the balance in the account after n deposits. Okay, notice again, I don't say years because that gets me a little confused. I want to think about how many deposits are going to be. There are going to be 18 deposits. That last one is going to go in, and then we'll see. It's probably just going to come right back out again, but that's okay. Okay, and then we're going to set up the following geometric series. We're just going to start by writing out the first couple of terms. B sub 0, after 0 deposits, we have $0. Okay, B sub 1, after the first deposit, okay, we're going to say that, well, sorry, I forgot to define one variable. Let's let x equal the unknown deposit value. Okay, so each deposit has value x. So again, b sub 0 is equal to 0. We haven't made any deposits. B sub 1 is going to equal x. No interest has happened yet because we just made the first deposit. B sub 2 is going to be that first year, so X amount of money has been in the bank for 1 year. So X times 1.045, because that made 4.5%. And then the second deposit's going to go in. Okay, B sub 3 is going to take this amount of money that's been in the bank, 1.045 plus X. Okay, that's how much money was in the bank for that whole second year. That amount is going to earn interest of 1.045, and then we're going to make a deposit immediately. That's when I start counting B sub 3 is immediately after that deposit. Okay, and then I can simplify this to be x times 1.045 squared plus x times 1.045 plus x. And you can see there'll be a little bit of a pattern emerging. Okay, so after skipping down, I want to make 18 deposits. Okay, I'm going to have x times 1.045. Now I look at this, the subscript is 3, the exponent is 2. So if the subscript is 18, the exponent is going to be 17. I know I'm going to have 1.045 to the 16th. It's going to go all the way down to x. Okay, good. And this on the right side of the equation is a geometric series. Okay, if you're careful about it, you'll say, I'm going to call this the first term. Even though it's at the end, I'm going to call it the first term. Because that way I can see that I'm multiplying by 1.045. If I called this one the first term, then I'd have to be dividing by 1.045. And I don't want to introduce any fractions into this. I don't want to. So that's my first term. And how many terms are in this sum? Let's see. There's really a 1.045 to the 0th power right there. So if I'm counting from 0 to 17, I actually have 18 things. Right? So 0, 1, 2, 3, 4 is 5 things. So 0 up to 17 should be 18 things. Okay, so it's an 18-term geometric series. Okay, so that should equal my fraction that I know is a geometric series. First term, x, times 1 minus the common ratio, which is 1.045, raised to the n, number of terms, 18, all over 1 minus 1.045. And this equation the balance in the account after 18 deposits should be the goal. Okay? And then I'm going to solve for x, multiplying both sides by the denominator. Actually, I'm just going to multiply by the reciprocal of the fraction without the x in it. So I'm going to do 300,000 times the denominator divided by the numerator. It's 1.045 to the 18th power. Okay. And then I can get my calculator out and I can just type that in. 300,000 times 1 minus 1.045, 45, divided by, now I need parentheses around this because I have to divide by a subtracted quantity, 1 minus 1.045 raised to the 18th power. Okay, this number hopefully should be a little less than 16,000. Good. It's quite a lot less. It's $11,171.07. So that's 11171.07. Okay, so what we're saying here is that Edith's parents can earn $300,000 in 18 years by investing $11,100.71 per year. Okay, let's just see how much money they earned in interest. Well, if I take that number and I multiply it by 18, you can see how much they actually invested. $201,000. So 11171 times, 0.07 times 18 is equal to 201,079.25. 201,079.25. Okay, so what that means is that that Edith's parents invested this much, and that the difference, which is roughly $100,000 difference, so roughly, what's that, $99,000, was earned in interest. Okay, that's a lot. That's free money. Okay, that's money that the bank gives you just for keeping your money there. Okay, that is equivalent to saying, I guess that's a third of the amount of money that they wanted to save. So they earned roughly 1/3 of their goal in interest, which is sort of like saying, 33% off of it's like a 33% off of college coupon. I mean, that's a big deal, right? If somebody came to you and said, "Here's a 33% off of college education tuition," you'd take that coupon right away. That's what the bank is offering if you choose to save your money over a long period of time instead of shoving it in your mattress. So I hope that makes sense. I hope the use of the geometric series is helpful. Um, and I think the lesson learned here is really save your money, save it early. And I think you'll find that you can do lots of examples like this. You can just make it up. If you raise this interest rate to maybe 5%, you'll see this number 11,000 goes down. If you make saving money, let's say you start saving before your child is born, maybe 25 years, you'll see this number go down even more. Okay, that exponent is going to be the one that really drives the ship here. Obviously, this number is effective as well. And obviously, changing the goal that changes things as well.